In this question, we're giving that a bouncy ball is dropped from a height of 5 meters. The coefficient of restitution between the ball and the ground is 0.8. Assuming air resistance to be negligible, how many bounces will it take until the ball reaches 1 meters or less? So I think the first thing we could do is draw a diagram. Suppose that's the initial height of the ball, which is given as 5 meters, and it moves downwards in this direction. Suppose this is the ball when it hits the ground and has a velocity of v. After the ball bounces, because the coefficient of restitution is given as 0.8, it suggests that it will lose 20% of its energy, so now the velocity will be minus 0.8 v if we consider downwards as positive. So now it would go up a certain height and then again go down. So after every bounce, the speed would be 0.8 of what it was before. So the initial gravitational potential energy of the ball is mgh. We know all these values, but I'm just going to leave it in this form and sub everything in at the end. So first of all, we can find an expression for v. So we know that because there's no air resistance, all of this gravitational potential energy would equal half mv squared, which would be the kinetic energy at the very bottom. This means that we can say that v squared equals 2gh and v equals square root of 2gh. Now, if we consider 0.8v, we know that after every bounce, the kinetic energy, so after, for example, the first bounce, okay, so in the first bounce, the kinetic energy would be half m 0.8v squared, and the height after the first bounce would be mgh1. Second bounce, in this case, would be 1 over 2 m 0.8v times by 0.8, because it's being times by 0.8 again, squared equals mgh2, where h2 is the new height. Now we can sort our pattern. So in the first bounce, it was 0.8 to the 1. In the second bounce, it's 0.8 squared. So in the nth bounce, it would be 1 over 2 m 0.8 to the n v squared equals mghn. So where hn is the height after nth bounce. Now we can take this out and say 0.8 to the 2n, because it's squared, times by m times by v squared divided by 2 equals mghn. We want hn to be 1 meter or less, so we can sub in hn as 1, and we can also cancel out m's on both sides. So this will give us, if I bring it there, this will give us 0.8 to the 2n times by v squared divided by 2 equals g times by 1. Now we can get n on its own, so 0.8 to the 2n equals 2g over v squared. So 2n equals log base 0.8 brackets 2g over v squared, and n equals log 0.8 to the 2g v squared over 2. We know from the start that v squared is 2gh, so we can sub that in. N equals log base 0.8 2g over 2m, so what was it again, 2gh. It wasn't m, it was just 2gh over 2. The two g's cancel out, so we can just get log 0.8 to the 1 over h over 2, and we know that h equals 5. Now we can just sub that into the calculator and find out an answer. So in this case, if I sub it in now, log 0.8 to the 1 over 5 divided by 2. Have I done a mistake? 2gh, and that would be g. Yeah, no. So n would equal 3.606 something. Now obviously we can't have a decimal number of bounces, and we're told that we need to find a height of 1 meter or less. So we just round this up and say at n equals 4, the height would be less than 1 meters. So this is our final answer.